So probability is part of the study of math, and as we were talking about in the previous video, it's coming out of this idea of set theory. The basic idea is we're going to create a fraction. Our fraction on the top is going to have a numerator part, numerator, that talks about number of desired outcomes, and then we're going to divide that by the bottom, the number of total possible outcomes in the denominator. No matter how far we take this idea of probability, the basic idea is going to keep on being this division fraction. So you're going to find the events, and then we're going to want to count them. When we're talking about counting, you want to start thinking again of combinations and permutations, as well as the multiplication principle from the previous sections. All right. Just as an aside, statistics versus probability. Statistics, I take a small sample, I look at some of basically the events, I look at a couple of events, and I use that to predict everything that's going on. Probability is more about saying, I know everything that could happen. That's my sample space, my universe in the set theory world. Now I'm going to figure out what's the chance that a particular event happens. So let's talk about it in terms of looking at some dice again. So let's look at some ideas. Let's find out what the chance is that I have 3. What is the chance that I roll a 3 on a dice, or they sum to 6? Well, let's highlight those two things. The chance that I roll a 3 will happen down this row, and it will happen down this row, because this is a column, not a row. On the other hand, my chance of rolling a sum of 6 happens along this diagonal. 5 plus 1 is 6, 4 and 2 is 6, 3 and 3, 2 and 4, 5 and 1. What I do is I count up my total possible, and that's going to be my denominator. So I create a fraction bar. How many are total possible? Well, there's 6 ways the dice can go here, 6 ways the dice can go here. 6 times 6 gives me 36 different dice combinations, and I could count through them if I wanted to, but I don't. Then on top, how many different options do I have? Well, I'm trying to find out the chance that I roll a 3 or that they sum to 6. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 ways I can get 3. And there's 1, 2, 3, 4, 5. There's 5 ways that I can get a sum of 6. However, I have to be careful how I count, because these events are not mutually exclusive. And when you're doing probability, you need to make sure you don't double count. Just like when we were doing survey problems, you had to do subtractions through the different Venn diagrams to not double count. You need to watch it here. So let's talk carefully about what we've got going. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 different things here. Now, if you like, you can reduce this. 15 is 5 times 3, and 36 looks like it will be 3 times 12. So I can cancel this out and say my final probability is 5 over 12. But notice how I was careful to not double count. When you talk about or, we do have this idea that there's 1, 2, 3, 4, 5. There's 5 different ways that I can get a sum of 6. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's 11 different ways that I can get a 3 to be rolled. If we added these together, I would get myself 16 out of 36, but I had to get rid of this one that I double counted here, so that went to 15. So just watch out when you're doing these probabilities that you don't double count. Some of the work inside the homework section helps you focus through and make sure that you're not double counting for anything. All right, so that's one thing we could do. Let's erase off our dice here. And let's talk about some other probabilities that I could have with dice. once you know something about a particular system that you're dealing with, a particular set of experiments, you always know what the total possible outcomes are. With dice, it's always going to be 36 when you're rolling 2 of them. Then you're just going to have to figure out what your condition on top is. What is the chance that you roll even? Well, let's see. 1 and 1 is 2. Here's a set of evens. That's 3 more. Here's another set of evens. Here's another set of evens. Here's some more evens. Here's some more evens. So I can count up all those things that have been highlighted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I get myself 18 out of 36 ways that I can sum to an even number. Again, you could reduce that if you liked. 9 goes into 18 2 times. 9 goes into 36 4 times. You reduce this further. That's called 1/2. You might even call this 50% or 0.5. Any of these are perfectly fine things to do in terms of talking about that. You also talk about complement. What's the complement of even? Well, that's all the odds. And this is where we get our first interesting formula, I think, that we talk about with probability. If I have an event and its complement that are everything, so if an event as well as that event's complement end up equaling the whole sample space in terms of size, well, then I can talk about probability. So they talk about, just like we talked about numbers before, and so, I'd have like, n of s, and that would be, 13, and that would be how many things were inside of s. Well, probability of an event E happening is going to be the ratio of desired outcomes divided by total possible. So if capital E is even and E complement is odd, you either get to be even or odd in rolling these dice and doing these sums. So the probability of getting some sort of dice, if I'm rolling dice, is going to be 1, which is 100%. We've just figured out the probability of getting an even is 1/2. So if I'm trying to figure out what the probability of E complement has to be, well, we know what that's going to be. It's going to be 1/2 as well. So you've got this formula that you have that can let you figure out what's going on. Notice this only works when your 2 events together end up equaling the entire piece. If I was talking about here, what is the chance of the cat getting these 2 colors versus these ones? Those don't add up to everything. There's all sorts of other colors that happen on here. So when you're doing your counting up and when you're trying to use this formula where an event plus its complement equals up the whole thing, you have to be careful what your event is and make sure that the complement is actually everything possible.